Okay, so again, we're gonna do number 8 and 9. These are the last two things that we need to do. You got your notes, you have a graphing calculator. We are not gonna do number 10, so don't worry about it. And then once we're done with this, then you can do your 2-8 homework. So I want you to work on that and have that next class, okay? So number 10 is a lot like number 7. It's one of those reciprocal functions, so we're going to combine our two fractions into one fraction, and then we're going to graph from there, okay? This one has something a little bit funky. I told you that I started making a video, and then I like hit something, I was like, oh shoot. And so I had to stop my video and like look it up, but now I'm fully prepared to talk about it. It's just a special case that we're not used to dealing with, so I just want to be able to talk about that. Okay, so let's start on what I think is the easier algebraic part, but sometimes causes mistakes that lead to the rest of the problem. Let's combine these two fractions into one fraction together, okay? So I'm going to multiply by the opposite denominator. So that first problem, I'm going to multiply by x minus 1 to both the top and bottom. And then my second fraction, I'm going to multiply by x plus 3 on top and bottom. What that's going to do is get my like denominators. So now I'm going to have x minus 1 and x plus 3 in the denominator. And I'm going to urge you to not multiply out, do not distribute out that denominator, okay? So I'm going to leave it, when I combine these two fractions into one, which you're welcome to keep it as two separate ones and then later combine it into one. I'm going to combine it into one right now, and I'll combine my like terms in a second. So I'm going to distribute, so I've got 5x minus 5, and then I've got 3x plus 9. I do want you to be aware, every so often, this is a negative, this is a minus in between them. So make sure whatever sign that is goes with the number that you're multiplying. So if it's -3, I'm going to distribute -3 to everything. Okay, now it's still going to be that less than 0. And I just want to combine my like terms. I want to take my x's, I want to combine them together. 5x and 3x becomes 8x. And then -5 plus 9 is going to be plus 4. It's all over x minus 1, x plus 3. That part is done. Now we're ready to sketch the graph for this, okay? And if you remember, I told you that the two things we have to find with this are my, bless you, are my vertical asymptote and my x-intercept. That's where the change happens. So if I'm actually going to scroll back up on my notes for a second. If you remember my vertical asymptote, that's where the graph was negative, and then after that vertical asymptote, it switched to positive. And the x-intercept is where it was positive, and then it switched to negative. So that's where the changes are happening. Okay. So my vertical asymptote on this one, I actually have two. I've got +1 and I've got -3. Okay. My x-intercept, I can set 8x plus 4 equal to 0. And so x is going to equal -4 divided by 8 is -1/2. So those are my points of change. Okay, on the other problem, do you remember how I also made you find the horizontal asymptote that helped us kind of guide our graph? We're going to find it, but it's not going to do what we want it to do. So we're going to talk about that. So that was the point of the video that I messed up, and I was like, oh shoot. I was like sitting in the teacher's lounge and I was like, oh no. And I had to like stop everything. So if I find the horizontal asymptote, if I look at this equation right here, I have 8x on top. And I know that I'm in factored form on the bottom, but if I were to multiply those two together, I get x squared on the bottom. Do you remember what my horizontal asymptote is if the exponent on top is smaller than the one on bottom?
0.
0. It's 0. So my horizontal asymptote is going to be 0. Okay. Now some of you might already see the problem, but if you don't see the problem, let's start putting it together. Let's start putting it on a graph. Graph it. I've got my vertical asymptotes are at 1 and -3. My x-intercept is at -1/2. And then it says my horizontal asymptote is at 0, so that means that my horizontal asymptote is here. Okay, normally we say asymptotes, we never touch, right? We never touch, we never cross. The reason we haven't talked about this is I just feel like this concept is not really an academics concept. That's why we don't really discuss being able to cross the horizontal asymptote. When it's in the middle of the graph, you're allowed to cross it because that horizontal asymptote is more like an axis. What the asymptote cares most about is the end behavior. So I can't cross it when we get to the ends, bless you, of either graph. But that middle of the graph, it's not as strong as of a barrier and we're allowed to cross it. So this graph right here is not gonna have like a parabola in the middle. It's gonna kind of have this more like cubic kind of function going through. And then what we would need to do is to figure out if it's on top or on bottom for the next ones, is we'd have to plug some numbers in. So I'd want to plug a number in that's bigger than 1 to see if I'm gonna be on top or on bottom over here, and then same thing over on this side. Once we plug this number in once, I'm gonna give you a shortcut so you don't have to do it again, okay? Let's plug in an easy number, let's plug in 2, okay, that's probably the smallest number I can plug in. So I'm gonna plug in 2 and I'm gonna see, is it gonna be on the positive or the negative side? And when I say plug in, I'm going back to my original, or to this function right here. I've got a lot going on, let me erase a couple of things. I'm looking right at this function here. And I'm gonna plug 2 in there, so I've got 8 times 2 plus 4. Well, that's gonna be 16 plus 4 is 20. And then 2 minus 1 times 2 plus 3. Well, that's 1 times 6, so that's gonna be 6. Is that a positive or a negative number? Positive. And then if we do the other side, it's gonna match that same one. Okay. I don't like this, I don't like what I'm gonna have to do to explain this. Let's adjust this, Macy.
Isn't it supposed to be 5 in the bottom?
Oh, it is 5. Yep. Will it still give me a positive number though? Yeah, it will still give me a positive number. Okay, what I am stressing out about is that we're just getting into skills I just don't need you guys to know. Okay, let's do this instead. Do you remember how I showed you that sign chart the other day? And you guys kind of gave me gross looks about it. Where did I put it up? Over here, maybe? We had a sign chart where we had like plus and minus and then plus. Do you guys remember looking at that? Okay. I showed it with F period yesterday on our rational function because rational functions should always alternate. It should always switch from one to another. So you just have to look at one of the categories. So like yesterday, we looked at the category that had 1 or 0 in it. And then from then we just flipped negative, positive, negative, positive, negative, positive. That's what I want to see on this one too, because in order for us to do this graphically, there's a lot more skill set with graphing that rational function that I will never ask you, okay? So instead, I still want to stick with the 2 things that matter to us, vertical asymptotes and x-intercepts, okay? So I'm gonna put -3, I'm gonna put -1/2, and I'm gonna put 1 on my little sign chart. We just have to go to one of those intervals and figure out if it's gonna be positive or negative, and then we'll alternate from there. Okay, I always go to the one that has 0 if possible. If I can't go to 0, I go to 1, find the easiest number to plug in. So we're gonna plug 0 in, because that's in that middle interval between -1 and 1. If I were to plug it in, just like we plugged 2 into, and I guess we could use 2 since we found out what that one was, but I'll prove it with 0 as well. If we plug 0 in, I get 8 times 0, which is 4. And if I plug 0 in here, I get -1 times 3. And that's gonna be a -3. When I plug 0 in, I get a negative number. Okay? That means I'm gonna alternate my sign. So if this interval is negative, the intervals next to it are both gonna be positive. So the interval from 1 to infinity is going to be positive. Which is what we just proved when we plugged 2 in, right? I'm going the other way. The interval from -3 to -1 is also positive. And then we have to alternate back. This last interval is gonna be negative. These are positive. That's negative. Because this graph is too hard to just draw a sketch of, and because we won't necessarily have our graphing calculators, this sign is the best way to do it. Okay, now let's look at what we've given to us. They want us to do our less than 0. So do I want the ones that are negative or do I want the ones that are positive? Negative. So give me those intervals that are negative right there. The first one, right? What's that first interval gonna be? So what? -3. What's my other interval that's also negative? -1/2, 2, 1. Most of them you should be able to graph like the one that we did above, but this one was a funky one, so we had to not graph that away. We had to use our side chart. Did I interrupt a question? I'm sorry. No, okay. I believe your homework looks more like number 7, but I wanted to go over it in grade. Okay, the last thing I do want to go over is an easier problem. It's actually one that we've done before. Number 9 is a word problem, so that kind of scares us immediately. But as we read it, you're going to recognize that we've already actually tested ourselves over this. It says Dixie's Packaging Company has contracted another firm to design boxes. Ooh, do you remember those word problem boxes that we've already done? Remember when I stood in front of you and I took paper and I like cut the little corners out? The exact same problem right here. I'm gonna tell you right now, there's a box problem on your final. That's why I'm bringing it up again, because I want you to do this on your final too. We want the volume to be at least 600, okay? At least, what inequality sign should I use to be at least? Let's see. I want the volume to be greater than or equal to, right? 600 is the smallest thing I can have. I want anything bigger than that. All right, and so I'm taking this box and it says squares are to be cut out of a 20-inch by 25-inch piece of cardboard. And so you remember we cut the little corners out, so I'm going to cut a corner out, and each of those corners are X by X. This may require a little bit of memory, but do you remember what my new sides are once we cut that off? What's this top side? It was 20. What's it going to be when I cut X off of both sides? 20 minus 2X. Awesome. Good job, guys. What about the other side? That was 25. What's it going to be?
25 minus 2X.
Amazing. And then when I write my volume equation, we use those two new expressions for my sides. Those are my length and my width. 20 minus 2X, 20 minus 2X, or 25 minus 2X. Do you remember what else we need to represent the height of this new box? X. Very good, Rosie. So those edges that we cut X off of, we're going to fold up and they're going to be X high. So I think of it, volume is X times 20 minus 2X and 25 minus 2X.
You graph that?
Graph it. I want one of your X or one of your Y's to be X times 20 minus 2X times 25 minus 2X. I want your other Y to be 600. And we're going to see where they intersect and where that interval is. So I'm going to take my graph. Oh, maybe not. So I'm going to take my graph and I'm going to put in 2x times 20 minus 2x times 25 minus 2x and then 600. We gotta play around with your window a little bit. I want my window for my Y max at least to be bigger than 600, so I may put 1,000 in so I can hopefully see enough. I don't need anything for a min. I'm gonna put 0 for both my X min and my Y min. And I'll leave my X max at 10. We'll see if that makes sense. Well, actually, we do know what it should be, and ten actually is the right answer. Do you remember in these problems I used to ask you for domain? What's the smallest amount I can cut off a piece of paper? It's the smallest amount you can do of anything. Even smaller, 0. Smallest amount I can cut off is 0. And if I'm cutting something off of both sides, what's the biggest amount I can cut off in this situation?
600?
Not 600, that's my volume. Katie, why is it 10?
You can't have over 10 on one side.
Good. My shortest side is 20, so I can cut exactly down the middle. I can cut 10 off of one side and 10 off of the other side. And the 25 is bigger, so that doesn't help with my limit. So 10 is actually the perfect number. I'm glad I left it at 10. Graph it. Oh, beautiful. Now they want our interval where we are at least 600. Is that above my 600 line or below my 600 line? Above, so that's this interval right here. What do I need to do in order to figure out that interval? That would be the max. Intersects, my intersections. I need to know this point to this point, because that is my interval. Trace, intersect, left bound, right bound. My first one's at 1.7, and then my second one is at. Oh no, a commercial. My second one's at 6.2.
Does this mean there's a box problem on the test on Monday, or is this just reveal? Okay.
I'm gonna put a box problem on the test on Monday. At $100. All right, our volume then is gonna be the interval between these two. Am I gonna use parentheses or am I gonna use brackets? Brackets, because it's at least, it could be that number. If I say I want at least a 90 on the test and I get a 90, then I'm happy because I got at least what I wanted. Okay. All right, I'm sorry that problem number 8 is such a mess. Please don't lose any sleep over it, especially my F period who has to watch this on YouTube. I'm sorry. C period, even though you guys got in real life, doesn't make it any easier. So don't let number 8 stress you out. Number 7 should be like what your homework looks like, okay? And none of it's on the quiz that you're about to do right now. Yes, Jonathan. Yep, nothing from 2.8 is on the paper I'm about to give you right now. Okay, so now you have the rest of class to complete that paper. Let's keep it civilized in here, and then you also have your 2.8 homework, because that will be due on Friday. Yeah. That's the